So welcome everybody. This is the first of a brand new series of webinars that we're going to be running. We're going to be running them every 3 weeks. So today is the 14th of July 2021. We're going to run them every 3 weeks from this point, always on a Wednesday, always at 5 p.m. And they are going to be in the same vein as the webinars that we ran last year during the first lockdown of COVID, that we are going to look at in-depth, detailed topics. They may be functionality that we talk about all the time. It might be things like lighting controllers, it might be schedule blocks, it could be whatever, but we'll look in really, really finite detail into that particular function so that all of you are really, really up to date with exactly how that works and how best to use it. For today's topic, I picked today's topic because what I see regularly through update training sessions that a lot of people struggle with is heating. And not just in config of configuring heating systems, but also actually how heating systems are laid out. I think it would be fair to say that many partners are smart home engineers, electricians, AV engineers, and much like cats, you have a little bit of an aversion to water. So hopefully we're going to tackle that fear a little bit today, make you a little bit more comfortable with heating layouts, with heating systems, how to configure them, how to get them working perfectly. Now, I will just preempt this by saying I am not a heating engineer. I would say that I have a fairly good working knowledge of heating systems, but I'm not 100% on them. So I will do my absolute best to show you through a heating diagram and where we put various different bits of Loxone hardware. We'll then look at the configuration of it as well. We'll look at the app, and together we will follow this journey. We will be taking a look at 3 different heating layouts. I would say these are the 3 most common layouts that we're likely to see in the UK, all based around a gas boiler. If it comes to something like a heat pump, then the principles are much the same. Nothing really changes. What we're going to look at is a combi heating system. So this is obviously hot water on demand that we don't need to control, and then we just need to send a demand signal to the boiler when we want hot water into radiators. The next will be an S-plan system. So this is a system that will have one zone going off for, let's say, radiators, and another zone for most likely a hot water tank. And then finally, we'll take a look at an S-plan plus system. So this is the same as the one before, except it's now got an extra zone or an extra several zones on top of that, maybe to feed a manifold, or because it's a large house, the radiators might be split across 2 zones, however it may be laid out. Okay, so now that that is out, now that that is out of the way, let's get started. At the end of today as well, there will be plenty of opportunity for you to ask me any questions that you have around the topic at hand, and maybe a few extra ones as well. And I will also at the end open a poll where you can request the topic that you would like to see in the next session in 3 weeks' time. But without further ado, let me share my screen and let's get started. So hopefully I've shared the correct screen this time, because I always make the mistake of showing the wrong screen. I think I have. Should be a nice blank green screen that just shows the Loxone mini server in the background. Wonderful. So as I mentioned, we are going to take a look over 3 different heating systems and how we can install them and configure them within Loxone. So I have prepared myself this wonderful little PDF file here just to show you through these 3 layouts. So the first one we're going to take a look at is a combi system. A combi system is the simplest of heating systems imaginable. You've got a combi boiler, it's hot water on demand, and then you're generally feeding your radiators throughout the rest of the house. This is the heating system that I have had through most of my adult life, because I've mostly lived in flats. So I've just had a combi boiler, and on a traditional system, that would be then a timer or a thermostat on the wall. In the background, really, the only thing we have to do from the mini server is send a trigger to the boiler to tell it that we need heating. This is obviously done through a relay. That could be a relay on the mini server, it could be a nano IO Air, it could be a nano 2 relay tree, doesn't really matter. And I would say that most combi boilers, it's a switched live, so that you send a live signal into the heating command, and that's what tells it to come on. And that's exactly what I've drawn here. we've got a permanent live and a switched live. The switched live is being fed through a relay in Loxone. Nice and simple. How that is going to look in config. Well, here I have config ready with very simply just a mini server. And I've then created a few valve actuators. So what I've done is we're going to keep the config nice and simple. We're not going to look at doing an entire house because, to be honest, as soon as you get the idea of how to do a couple of rooms, it's the same for the entire house. We are going to look at the central side of things, so the boiler side, and we're going to look at 2 rooms in the upstairs of a house, which is going to be the bathroom and the bedroom, and we're going to look at 2 rooms downstairs, which is going to be the living room and the kitchen. The reason being is when we start moving on to the more complex heating systems, we can show the difference between underfloor heating downstairs and radiators upstairs. So what I've done is I've created a set of valve actuators for each of the style of systems that I'm going to show you. So you can see here, bathroom valve actuator, bedroom valve actuator, and I've named Combi after them. This is because this config file will be available to you, for you to look at afterwards as well. I've also got a few tree devices as well there, like some switches, maybe for some temperature readings. So we're going to start with our Combi system. And that's what I'm going to name the page. Now, however you choose to do your page layouts, ultimately up to you. Generally speaking, I would recommend having a page per room and then having a page at the end, which is for your central parts of the system, whether that be burglar alarms, fire alarms, heating for the boiler, whatever. However, for the sake of this webinar, to keep everything nice and condensed and all in one place, I'm going to do a page for each of the systems that we're controlling. So I'm going to name this page Combi System, and I'm just going to set a default category of climate so that everything that I put onto this page is given the category of climate. You'll notice in the latest version of config, there is a couple of little changes that have happened here. There is no longer a heating and cooling category. There is a heating category, but the heating and cooling category has been replaced with climate. That's because we might want to bring ventilation in as well. It's a more all-encompassing category. And then for rooms, the room that used to be called whole house is now called central. And again, that is to be more flexible because we call it the central page of the app. We might be doing an office, we might be doing a commercial building. It just gives us more flexibility. But I'm not going to worry about default room, just default category. And then we're going to start configuring. So as I said, we are going to have a bedroom, bathroom, living room, and kitchen as the 4 rooms of this house that we're configuring. We're going to assume it's just a 4-room house. And then it's a combi boiler centrally. So this layout here. Now, when we're doing heating configuration, I would always recommend starting from the plant side and moving your way towards the rooms. So that's exactly what I'm going to do. I'm going to start at the plant side. Now, the plant side in this instance is the energy source. The energy source is the boiler. So first thing we need is the function block that controls our boiler. And this is very, very simple. It is a climate controller. A climate controller is designed for any source of heating or cooling. In this case, we have one heating source, which is our combi boiler. So I'm going to add the climate controller to this page. I'm going to give it the room central because that's where it goes. It's controlling the whole house. And I'm also going to name it because this particular block is visible in the app with this use tick box. So I'm going to give it a more sensible name. I'm actually going to give it a name of central heating. My reasoning is that is a term that is consumer friendly. A consumer knows what central heating is. So I'm going to call this function block that. Then we have one relay that turns this boiler on and off. We have this relay here from the mini server is going to the switch live of this combi boiler. So the next thing we need is that relay, digital outputs, and I'm going to assume that this first relay is our combi boiler trigger. So I'm going to call it as such as well and drag it onto the page. The climate controller has several outputs. It has an H output for heating. It has a C output for cooling, and a QF output for an auxiliary fan. There are a few others as well, but you're rarely going to use them. The reason why there is a heating and a cooling output is because certain systems might only be able to do cooling, so we want to use the C. A boiler can only do heating, so we want to use the H, but something like an aircon system can do heating and cooling, so we want H and C to be able to switch between the modes. In this instance, heating only, that trigger goes to H. The story then obviously doesn't end there. As always, with every function block, there are some parameters that we need to change. There are quite a lot of parameters on the climate controller, and most of them you won't need to touch. Most of them really only start having relevancy if you start talking about heat pumps or you start talking about HVAC systems. With general boiler-based systems, there's only a couple that matter. The first one that does kind of matter is the heating type. Anytime you are just doing super simple control, just turning something on and off, even if it is heating and cooling, please select this option. You'll see a bunch of the other parameters disappear. The reason is the heat pump electric option includes things like minimum outdoor temperature and sequencing and threshold and filter times. Now, this is really only relevant towards large HVAC systems or heat pumps where you have granular control of them. So not just a heat pump you're turning on and off. So even if you were doing an electric heating system, for instance, an electric underfloor heating mat, I would still be tempted to set oil/gas there, just to get rid of all of those extra parameters. Then, the ones that matter in terms of the parameters, we have the mode. The mode dictates whether this particular energy source can do heating and cooling, only heating, or only cooling. And the default mode is 0, meaning if you leave it as 0, it might think, depending on how you do the rest of the configuration, that this boiler can cool our house down as well as heat it. Now, obviously, this is not the case. So what I'm going to do is set that to 1. By putting the mode at 1, it will mean that we heat only, which you can see down here in the description. 1, heating only if there is sufficient demand. The next parameter that I think is rather important is the switch on threshold, parameter STR. This is a percentage of the valve actuators or the valve openings in your system required before that boiler will turn on. And the default is 30%. Now, it's really important to remember that all of this is an analog system. So it does not mean 30% of rooms. It means 30% of valve openings across the house. I will come to explain this more detailed later as we start adding valve actuators, but a Loxone valve actuator, for instance, is proportional. It's 0 to 100%. So if you had 4 rooms, each with 1 valve actuator, then we're looking for 30% of the total openings, and each room is 0 to 100%. If I put 2 valve actuators on a single room, that room now has a 200% potential demand. So it will also look at the number of valve actuators you've put onto a room controller. Meaning, if you have a very large room that might have 3 or 4 radiators, then that room will have a higher weighting than other rooms might. Now, the reason that the switch on threshold exists at all is mainly there around efficiency. Because if we have no switch on threshold, the heating can just turn on and turn off whenever the hell it likes. We might have one room in a property that is always colder than the rest of the house, but it heats up very quickly. An example that I would use might be a WC. If you built a WC into like the far end of your house, maybe where your entrance door is, it's going to have maybe 2 or 3 externally facing walls. It's a very small space. That room may naturally get a lot colder than the rest of the house. But if you turn the heating on just for that room, because that's the only room that needs heating, it might be up to temperature in 20 minutes, and then your boiler would turn off. Another 20 minutes later, your boiler needs to come back on again. 20 minutes, and that's short cycling. Something going on, off, on, off. Generally speaking, pretty bad for the life of your boiler, which is why there is a start threshold there. You can, of course, tweak it. If you find it's not quite right, I would recommend dropping it down by about 5% at a time until you find that Goldilocks zone. I'm going to leave it as is. All of these parameters down here don't really care about for a boiler-based system. The switching, the sequencing is really about if you want to have a certain length of time it's on and then a certain length of time it's off. Don't really care about it for a boiler. The last one on the climate controller I do care about is TA, whether you include the outdoor temperature or not. Now, of course, if you leave this ticked, you must have an outdoor temperature sensor. You mustn't leave it ticked if you don't, because it'll always think it's 0 degrees. And what this will do is as soon as outside exceeds this temperature, it will stop heating being able to come on, even if a particular room is under temperature. As soon as outside is below this temperature, it will prevent cooling from being able to come on. Simple concept. If you don't have an outdoor temperature sensor, which remember you can get from a weather station, weather service, or you could have your own third-party sensor. If you don't have any of those, please untick. And that is the boiler done. The next part of our heating system is the rooms level. Now, the first thing with the rooms, first thing to remember with the rooms is room sizes. So for all of the rooms that you create in config, you have an option to set a room size in square meterage. This is used in the background as part of that switch on threshold. So please set it. It doesn't have to be 100% perfect. Roughly right is better than completely wrong. The next part of the room level is obviously controlling the valve actuator in the room, and that is done through the intelligent room controller. So the intelligent room controller looks at the temperature of the room, compares that against what you want the temperature of the room to be, and decides, number one, do I need to open or close a valve actuator? And number two, do I need to send my demand signal to the climate controller to turn the boiler on? You'll notice there is an intelligent room controller and an intelligent room controller V1. V1 is the old one. Please don't use it. So I'm just going to add an intelligent room controller for each of those rooms I said we were going to do. So there is going to be one for the bathroom. And then I'm going to set the room over here on the parameters for the bathroom. There is going to be one for the bedroom. And again, I'm going to set the parameters there for the bedroom and call it bedroom. You don't have to rename them. The name doesn't really play much heed in the app. I'm just doing it for neatness. Another one is going to be the living room. And again, set the room as living room. And then finally, the kitchen. So there we have the 4 rooms of our particular house. Please only ever put one intelligent room controller per room. It doesn't matter whether you have underfloor heating and an aircon unit. They can both go on one intelligent room controller. If you put multiple intelligent room controllers in the same room, they will fight against each other. Because one of the biggest advantages about Loxone is its learning. What we will do is we will automatically learn how long it takes to heat up or cool a room down so that we can always get to the right temperature in the room at the right time without you having to constantly be readjusting your schedule. If you say 21 degrees in the bathroom at 8 a.m., the heating can turn on whenever it needs to before that point so it's at the right temperature at that time. So please, one room controller per room. Then we need a temperature reading in each of these rooms. Now, a temperature reading can, of course, be taken from a Loxone switch, either the touch or the touch pure. So in my living room, for example, I've got a touch switch on the wall, so I can expand that, take the temperature out, and I can assign it to the living room intelligent room controller. And you can see it goes on this input here. This used to be TI in previous versions of config, but TI was used elsewhere in config, so we had to give it a new symbol. And that is not a bug. That is the Greek letter theta, which is a standard, whatever you call it, for heating. So it is an actual scientifically used symbol for heating, which is why it's there. So touch switch in the living room, temperature input on theta I. I've got another touch switch in the kitchen, temperature to there. And then in the bathroom and bedroom, I haven't added myself a touch switch because remember, your valve actuators do also contain a temperature input if they are valve actuator airs. So the valve actuator air also has a temperature sensor built in. So bathroom valve actuator temperature into there, and then the same for the bedroom one. Bedroom valve actuator temperature in there. In less commonly used rooms, that can be a good way of getting a temperature reading without going to the expense of adding in an additional sensor or an additional device if you have nothing else in that room. Just make sure that it is a fairly modern radiator that isn't going to throw its heat out left, right, and center, and it's going to massively throw the heat of that temperature sensor out. But otherwise, there we have our temperature inputs. Outputs. At this current moment in time, I do not have the right output. If any of you are configuring your heating systems and you are putting your valve actuators on the H output here, this unfortunately is not correct if you're using a climate controller, because this H output operates completely independently of anything happening in the central system. It has no care in the world about what is happening centrally. It's only caring about its one room, meaning you may end up with a completely open valve in your bathroom, even though your boiler isn't on. So that is not the correct place. The correct place actually doesn't exist yet, because another part of heating in Loxone is making all of these things talk to each other, or rather making the intelligent room controllers talk to the climate controller. To do that, we need to assign the climate controller inside the room controller. So you can see here, you've got assign objects, click it, and then we have a list of our climate controllers. And you can add your climate controller in there. Specifically, you can actually add up to 3 climate controllers per intelligent room controller. And then you can tick whether it's doing heating, cooling, or both. The PWM tick box is if you're using third-party mains valve actuators. So I'm going to leave it unticked. So OK there, do the same here, and same here. So all 4 intelligent room controllers. And you can see now that the output has changed and it now says H1. This means that it is a valve actuator heating output that is linked to climate controller 1, which in this case is our central heating climate controller. Meaning if I added a second climate controller to this block that also did heating, I would have H1 and H2, allowing us to separate which output we use for which heating source. And this is then where our valve actuators go. So there's the bathroom, there's the bedroom, living room. So what have we got? Living room. And in the living room, I've considered that the living room might be rather a big room. So we've got 2 radiators in the living room. And that just means 2 valve actuators, both of them in the same place. And then finally, we've got the kitchen. Cool. Last thing for us to do is just have a quick look through some parameters, make sure these are all okay, and save in. Now, when it comes to parameters of intelligent room controllers, all of the ones related to heating set points, customer can do themselves in the app. So things like comfort temperatures, I'd much rather just let the customer deal within the app. So you can see we have a heating comfort temperature and a cooling comfort temperature. This is new. Previously, there was only a single comfort temperature, and then you set a tolerance each side. And you had to hit that tolerance above or below before it switched from heating into cooling mode. This is no longer the case. You now have two comforts, one for heating, one for cooling. As soon as you exceed either one, the mode switches. It's also now incredibly intelligent that it recognizes based on what you've assigned to the outputs if it doesn't have, for instance, cooling available. So there will be no option for us to do anything with regards to cooling in the app. It knows it can only heat because we've only put an output on heating. A little diagram one of my colleagues has made me to explain this in a little bit more detail is this. So this is how the heating logic works if you do have heating and cooling. So you can see as soon as you are below your heating comfort temperature, it will bring on active heating. As soon as you hit your heating comfort temperature, it will stop actively heating. It will still be in heating mode, but it won't actively heat unless it needs to. As soon as you exceed your comfort cooling mode, it will bring on active cooling. And it will then again be in passive cooling mode until you drop below your heating set point. Obviously, all of this with regards to cooling will only be available if you have something assigned to a cooling output. And you can now also assign a different shading comfort temperature for heating and cooling as well. If anyone needs this diagram, please let me know and I can share it with you later. For this system, it's a lot simpler because it is literally just heating. So really the only thing I'd need to worry about is any of the heating set points, which is comfort temperature heating. We have our economy set points, which is how far below and above comfort. Temperature for shading, we've got no shading, so I don't need to care about that. And then frost protection and heat protection. These are absolutes. So I normally say frost protection at about 10 degrees personally. Cool. And that's pretty much it. The other things that you can do, if you would like to, is you can also assign window and door contacts to the IW input. If you do this, then if a window or door in that room is open for longer than this parameter here, the heating will turn off. Because why throw the heat out the window? You can also assign a motion sensor or presence sensor to the MV input. And I am actually going to do that in the living room. So in the living room, I am going to put a motion sensor into MV. Could be motion, could be presence. I'm just going to use motion so that I'm not constantly triggering it when I'm speaking. What this will do is for as long as I am in the room during a normal comfort period, it will keep my comfort schedule on for me so that it won't just turn off at, let's say, 10 o'clock at night. As long as I'm still in the room, the heating will stay on for me. It can even be used, oh, I put that in the wrong place, naughty me. It can even be used that if you are not in a comfort schedule, as long as you are in the room for 30 minutes, it will turn it into comfort heating for you. Cool, and then I'm going to save that in. I can see a couple of hands raised at the moment. If we could wait to open mics until the end of the session. If you have something you want to ask directly now, use the Q&A and I can answer it as we go along. Just because otherwise, sorry guys, I will completely lose my train of thought. Awesome, so I've just saved that in. Let's take a look at it in the app. So, open up the web interface. Log in. Rooms. Here is our 4 rooms. We've got bathroom, bedroom, kitchen, living room. Let's go into one of them, living room. And here you can see we are currently in a comfort schedule because there is a default schedule set. My current comfort target temperature is 22.5 degrees. And as I was saying, it is intelligent enough because we haven't assigned anything to a cooling output that we don't have cooling available. It knows that we don't have it, so it's not even giving us the option. And things like temperatures, we can set in the app. And again, cannot set any cooling temperatures because they don't exist. So really, really nice and functional. Lindsay has asked, if you have 2 climate controllers, how do you say which one is 1 and which one is 2? You don't need to. all you need to know is which one is which. So if I added a second climate controller and I called this 2, and then I went into, for instance, the kitchen, and I added this in here, you can see that there is a group list here, but you can't change the order of the groups. But it doesn't matter, because as soon as I press OK, I now have my number 2 output. If you're talking about in which order does it bring those 2 on, then that is done through the heating and cooling tabs here. You can change the priority for which one is used in which order. Okay, Richard has asked, if we are using more than one switch in a room, do we average the temperatures of those switches? And the answer is, it depends on the room. If one switch is in a particularly cold area of the room or a cooler area of the room, and one switch is in a particularly hotter area of the room, I would probably always use the cooler one. If the switches are, well placed, both of them, I would consider averaging it. So really, it depends on the room. The recommendation that we have been given generally from heating engineers is to not average temperatures, to only pick a single point in the room to read from. So it really depends on the layout and the principles of the room. Another way that you could do it is you could actually use a function block called min-max, in which you can put all of your temperature sensors into the min-max block, and it will always output the lowest temperature and the highest temperature read in that room. So you could always be using, for instance, the lowest temperature from all of the switches in the room. But ultimately, it depends on the layout of the room. Cool. And there we have a working combi boiler system. Beautiful. Now, all of the concepts for the config for the other 2 systems I'm going to show you are pretty much identical. So the other 2 systems should be a little bit quicker to rattle through. But just to show you again, rooms, and we've got our 4 rooms here. In each room, you can see if we are or are not in a comfort period. Schedules can be set in the app. You can also put operating modes onto your schedules as well. So operating modes are freely creatable in config. I could, for instance, create one called webinar in config. So I could have operating modes, add a new one, call it webinar. And then in the schedule of my rooms, I would actually be able to add that webinar operating mode, and then I'd be able to do a separate schedule for that operating mode. And then through something like Automatic Designer, I could automatically put myself into the webinar operating mode on, say, a set date when I know that I'm going to be running one. So quite a cool bit of functionality there. So back to here, if we go to kitchen, for example, go to the schedule, I can actually go into here and I can add in that webinar operating mode that I've just created. And I can say that whenever a webinar is on, we want to be in comfort temperature all day long. And then anytime I say that I'm in webinar mode, we'll go to comfort 24/7. And I could do that, for instance, through Automatic Designer. But that is jumping a little bit onto another topic, so I won't go into too much detail with regards to that. You can also see, if I go to the central page, my climate controller. So the climate controller is visualized in the app, and it will tell you which rooms have a demand and which rooms don't. So you can see my living room doesn't have any demand because it's currently 26.3. It is actually pretty warm in this office because I forgot to turn, funnily enough, I forgot to turn the operating mode to webinar mode before I started this webinar for our office system. The reason that the other 3 rooms are showing 0 degrees is because those valve actuators that I've used for temperature readings don't actually exist yet. So it's always going to read them as 0. And there we have a combi system. Nice and simple. Next, we move up to an S-plan. And what an S-plan means is that we have one zone here for instance, our radiators in all of our rooms going through a zone valve. And we have another zone, for instance, for a hot water tank, again, going through a zone valve. So these are 2-port zone valves. They're either shut or open. So they either don't let water through or they let water through. Now, this obviously means that we want to make sure we open the correct zone valves for the correct parts of the system. Now, again, this can vary from manufacturer to manufacturer, from heating engineer to heating engineer, and I'm not an expert on this, so please take this in good faith. But here is a quick example of how we might do that in terms of wiring. We can actually do this in principle with 2 relays. The reason being is that a zone valve actually contains an inbuilt volt-free relay. You can see this here, common, normally closed, normally open. So the orange core is the common and the gray core is the normally open, meaning any time we power up that zone valve and that zone valve fully opens to let water through, this internal relay will switch over. So the common will then switch to the normally open. So this means that in terms of wiring in Loxone, what we can actually do is we can take our lives into 2 relays of the mini server, feed the other legs of those relays down to feed the zone valves, and then provide a live onto the common or the normally open of the zone valve, and then the other leg of the zone valves relays we can feed back to the switched live of the boiler. This gives us the advantage of making sure then that the boiler won't actually turn on until either one of the zone valves is opened. So it gives us a little bit of safety in the system as well. If we don't want to do it like that and don't want to use the relays in the zone valves, easy, we just need a 3rd relay from Loxone. 1 for the boiler, 1 for this zone valve, 1 for this zone valve. That's where your professional principles come into play of what you think is personally best. So now that we've got that covered, I'm going to create a new page. I'm going to call this page S-Plan. I'm going to set it a default category of climate again. And mostly it stays the same. We still have a climate controller. Boom. That climate controller is still for our boiler. We still have intelligent room controllers, so that is exactly the same. We have 1 for each room. So I'm not going to go into as much detail this time, just so that we rattle through this a little bit quicker. But we have bathroom, we have bedroom, we have living room, and we have kitchen. So all of this remains the same. The bit where it can change up a little bit is with regards to those zone valves. So if you are just triggering the zone valve and you're leaving it to the zone valve to trigger the boiler, it just stays as this. And your heating zone valve, which I'm going to do on another relay, so I'm going to call this a radiator zone valve, would very simply go onto the climate controller, just like our boiler trigger did last time, because it's the zone valve that's in charge of turning the boiler on. If, however, we are doing 2 relays, 1 to the zone valve and a separate 1 to the boiler, then that is when we would bring in an additional block called the intelligent temperature controller. Now, I'm just going to mention it at this stage because we'll do it more when we go to the S-Plan Plus. But the intelligent temperature controller can be used specifically for opening and closing zone valves. But at this point, based on the diagram we've done, I'm not going to go to that level. Everything else remains exactly the same. All of that goes like that. The rooms, we do whatever we want for the comfort temperatures. We assign them to our climate controller. This is where I made a little bit of a mistake. I need to call that central heating 2, just so that I can actually differentiate them. Otherwise, I'm going to have a problem of not knowing which one's which. So central heating 2, onto all of these. Temperature sensors, just the same. So we have our kitchen temperature, goes in there. We have our living room temperature, goes in there. And then we have our valve actuators. So kitchen on there, living room, S-plan, there it is, on there, living room S-plan here, sorry, just, there it is, on there, and valve actuators on those two as well. So bedroom, oh no, I've named two the same. So that there, and then bedroom S-plan there. And I'm not going to add the temperature sensors just because we already know how to do that, and I don't want to overrun just for the sake of putting a couple of inputs on. The bit where it gets different is the hot water tank, because obviously the hot water tank is something separate. We want to have hot water. Hot water is not heating. Hot water is so that we can have showers and have baths. It's its own zone valve. We're running it on its own relay. My advice, easiest and simplest way to do hot water is like we have always done in a conventional house with a schedule. Easiest way to do hot water. So I'm just going to throw a schedule block in there, and I'm going to call it hot water timer. And then that's just going to be the other relay for the hot water zone valve. Onto output AQ. And within the hot water timer, you can obviously put your schedule in there. Then, if you want to get really clever, something that you can do is a lot of hot water cylinder stats, in fact, all of them, under the hood is really just a relay again. It's amazing how many things in the real world are just relays. So if we take a look at a hot water cylinder stat, just a Honeywell one as an example, and take a look at the wiring diagram for it, you will be able to see that under the hood, it's literally just some relays. So again, you've got a common, a normally closed, and a normally open. So what we could potentially do, provided that it has a low switching threshold, which might take a little bit of testing just to make sure it does, we could potentially put 24 volts into the common instead of mains, and then out of the normally open here, wire it into a digital input. And we could then have a digital input that tells us when our hot water tank is at temperature. So I'm just going to call that HW cylinder stat. And that could actually go on the reset input of this schedule block. So as soon as that cylinder stat then flips the relay over, the input fires, which resets the schedule block, which blocks it from operation until the tank is back under temperature. And that is how, for instance, we could do an S-plan system. While that's just saving in, let me take a quick look at the questions, just see if there's any I can answer now. So Ian has pointed out that some valves aren't volt-free. So yeah, this is why I said your professional judgment comes into play. Some valves may not be volt-free, so you may have to apply a little bit of care with them. The other two questions I will cover at the end in a Q&A session. Cool. So with that saved in, just make sure it's saved. Everything else will look absolutely identical, so I won't look over the heating stuff for you because the intelligent room controls, the climate control are all exactly the same. What I will just show you is the hot water cylinder stat. I forgot to put it in a room, that's my fault. So you can see here the hot water timer is currently enabled, currently in a schedule period. If I then flick that digital input for the hot water cylinder stat reaching temperature, you can see there in the app, it shows that it's locked. And it tells me why as well. It gives me the name of the input as the reason it's locked. So that's quite cool. And that's then an S-plan system. Moving on to the final one, which hopefully will have just enough time within the time I promised you it would be. We look at an S-plan plus. An S-plan plus is a little bit more of an exaggerated heating system where we have multiple zones. This, for instance, could be a zone for upstairs where we have radiators, a zone for downstairs where we have a manifold, that feeds obviously underfloor heating, and a separate zone for a hot water tank. So in this instance, we have 3 different zone valves. Now, the underfloor manifold may also have a pump on as well. That's quite common. And again, various different ways of doing this, various different layouts. So I don't want to promise that this will be correct all the time, but in many instances for this particular system, you could again get away with doing it with 3 relays, a relay for each of the zone valves. And then again, using the contacts on the zone valves for triggering the boiler and also triggering the underfloor heating pump. You just have to be careful that you're not accidentally turning on the underfloor heating pump by opening the radiator zone valve, which this diagram roughly shows. So again, 3 relays, the 3 different parts. And then in terms of config, I'm just going to create a new page, call it S-Plan Plus. Surprise, surprise. Again, we have a climate controller. Boiler is always going to get itself a climate controller. And I'm going to call this one Central Heating 3, if I don't keep smacking the wrong things on the keyboard. This is now where the intelligent temperature controllers definitely come into play, because on the heating side, we now have 2 different zone valves. One zone valve for downstairs, one zone valve for upstairs. We need to switch the correct one depending on which area of the house needs heat. So to do this, we use intelligent temperature controllers. And we will need one of them for each zone valve. So we are going to need one of them for the underfloor heating zone valve, and I'm going to rename it just so it's obvious. And we will need another one of these for the radiator zone valve. So this is then where the system starts expanding, when we start adding in multiple zone valves. Now, the important thing about the intelligent temperature controllers is that by default, they are an independent heating controller, meaning they have no interaction with the climate controller. This is because on certain heating systems, they may be independent. There may be no boiler. It may be a block of flats that have a heat exchanger. But in this domestic scenario, we need to remember to say that it is linked to a climate controller, and then to say which climate controller it's linked to. And so now all 3 of these will work in tandem. We're then going to have those 2 relays for the 2 heating zone valves. So one relay for the underfloor heating zone valve, and another relay for the radiator zone valves. These go on the output QP of your temperature controllers. So the Rads zone valve goes there, the underfloor heating zone valve goes there, and your climate controller gets left with nothing attached to it. I'm just going to make sure that I do those parameters again, just there. So even though there is nothing attached to the end of this, it's still doing logic under the hood. Then, just because time's getting a little bit short, I won't do all 4 of the rooms this time. I'll just do 2. I'll do 1 room upstairs, 1 room downstairs. So again, that will be intelligent room controllers. This bit stays the same. So 1 intelligent room controller for the bedroom, which is on radiators, and then 1 intelligent room controller for the kitchen, which is underfloor heating. We still need to assign these to the correct climate controller. So we still need to do this on them. The extra bit we need to do is remember to put the correct rooms on the correct zone valves. So we double click on each of the intelligent temperature controllers and we tick the rooms that are triggered by those zone valves. So underfloor is just going to be the kitchen. Radiators is just going to be the bedroom. And this will ensure that wrong zone valves don't open and close. And then the hot water tank, we can do in exactly the same way with a schedule block. Save that in. And there is 3 different heating systems done in Loxone. Simple, eh? So remember, climate controller for every energy source. Intelligent temperature controllers if you have multiple zone valves on your heating system that you need to open. Intelligent room controller per room. And then remember to do the linking to link them all together so that they're all working in tandem rather than against each other. And then depending on where you put your valve actuators will depend on what you see in the app. If you only assign something to an H output of an intelligent room controller, then you will only ever get heating controls in here. And then this is the layout in the app. Customer in the app can change their schedules. They can put it to a fixed set point temperature if they don't want it to be in automatic mode. And they can change their temperatures in the app as well. Beautiful. All right, that is me done. So that is the end of the official webinar. Please, if everyone would just want to stay behind for a few minutes, we'll have a Q&A session, and I'll also do the poll for what we should cover in the next session. So let me just take a look through the Q&As now. I'm just going to stop sharing my screen for a minute so you can see me in nice big video. Who doesn't want to see that? Okay, so Dave, when saving a preset for the intelligent room controller, the current mode, automatic set / fixed set point aren't recorded into the preset. Is this a bug? Not 100% sure what you mean, I'm afraid. Do you mean that if you change in here, for instance, to a fixed set point, and then, for instance, then save in config, that it will overwrite that and go back to automatic? If that is what you mean, it's not a, oh, sorry, I just realized I wasn't sharing my screen. I just said I'll stop showing my screen, and then I showed something on my screen that I should have been sharing. So what I was just saying is, do you mean by that if you go in here and you change it from automatic to fixed set point and then save into the mini server reboots, that it resets? Because I just did it and it didn't, it stayed on fixed set point. If you'd like to clarify, just put your hand up and I can open the mic for you. Yeah, as Ian has pointed out, some zone valves can have odd switches that aren't volt-free and involve diodes. I, in fact, had a partner a little while ago who was reading something like 50 volts from his zone valve even when the relay wasn't closed. So yeah, that's where professional judgment comes into play, and you need to have a little bit of sense around you. Alan, previously led to believe that climate controller only worth implementing if there is a dedicated switch live for the boiler. Seems that's not true from what you were saying here. No, you should always have a climate controller for a heating source, and I've always taught that you should always have a climate controller for a heating source ever since the climate controller was first implemented. Don't know who told you that, I'm afraid, Alan, but you can have a heating system without a climate controller, it's fine, but you still need something to decide when the source should turn on or not. So if you've got a zone valve, for instance, it's fine to just have an intelligent temperature controller. That will work, the config will work, but you would lose, for instance, the climate controller visualization in the app where you can see all of the rooms nestled under it. So you'd lose a bit of functionality. Will there be a link for this webinar? Of course, it is being recorded. It will be available to watch on the online academy. Probably tomorrow afternoon, I will get around to loading it on there. What about cooling and air conditioning? I would need another hour to go over cooling and air conditioning. So I can't go into too much detail, but suffice to say, you get an extra climate controller for every aircon unit you have. You add that climate controller into your intelligent room controller in the room. You will then get an additional output for that climate controller on the room controller. If you leave heating and cooling ticked, it will be called HC2. And then you use the HC2 output for your fan speed, and the climate controller decides whether to turn the aircon on or off or not. But I tell you what, I've actually made it one of the options in the poll for the next session. So if you would like to look over air conditioning config in detail, choose that on the poll. Where would you attach the boiler signal on the S-Plan Plus? Well, based on this diagram here, there is no boiler signal because the boiler signal is coming from the zone valves. So the only thing I'm triggering is the zone valves. If I reworked it so that I was triggering the boiler through a separate relay and Loxone, then very simply it would just go onto the H output of the climate controller, just like it would do in a combi boiler scenario. Okay. Richard, how would you set up a single room with more than one zone valve? For example, Rads and UFH in one room. Okay, I think I know what you mean. So we have, for instance, in this config, we have, for instance, the kitchen has a radiator and underfloor in it, and each of these zone valves triggers that. If that is the case, then what I would do is I would just make sure that it's ticked in both of the intelligent room controllers. Intelligent temperature controllers. Simple. Then both zone valves will open, and then you just tie all of the valve actuators onto H1. So they all open at the same time, and it uses both of them. Oh, Scott, have I shared the wrong screen? I knew I would do that at some point. Sorry, guys. Let's share that again. So what I was just saying, Richard, if you have, let's say, a radiator and underfloor in, say, the kitchen, then what I would do is in the intelligent temperature controllers for each of the zone valves, just make sure that the kitchen is ticked in both of them. Then both zone valves open. Then just make sure that all of the valve actuators, both the ones on the manifold and the radiators for that room, go onto the H1 output. Then heat goes into all of those areas at the same time. Nice and simple. Keep it simple, stupid. Okay. Okay, Dave. So I take it you mean that if you set a fixed set point in a room and then you save the default, then save that as a preset for that room and then restore that preset, it goes back to automatic mode, not to fixed set point. To be perfectly honest, I don't know whether that is a bug, a feature, or an oversight. I would have to double check that with our software developers. Please, so that I don't forget, could you just ping me an email with that? And I can then, if I can replicate it, I'll ask our software team and I'll find the answer for you of whether it's a bug, feature, or oversight. Is the idea of H2 for the zone valve, so the zone valve opens and closes before and after the boiler is told to come on and off. When we say H2, what are we meaning? Are we meaning H2 on the climate controller, or are we meaning H2 on an intelligent room controller? H2 on an intelligent room controller is solely designed if you have a second source of heating. So it is not to say that it happens one after another. This is, for instance, if we had, I don't know, wet underfloor heating and an electric radiator. They're two separate sources, so we need two separate outputs to control the amount of demand to each one. That's what H2 on a room controller means. H2 on a climate controller, to be perfectly honest, I have never once used. It is designed to turn on after a particular runtime. So after your climate controller is on for longer than 60 minutes, H2 here on the climate controller will turn on. I've never used it. If your point is about making sure that valves open before zone valves do, so that you're not potentially causing pressure or too much stress, then I would actually recommend solving that in a much simpler way of just adding a switch on delay between your zone valve output and your zone valve relay, and then just delaying this turning on by a minute or two. Much simpler way of implementing that. Is it okay to assume that a valve can be replaced with a pump instead in an S-Plan Plus setup if there are no valves? That's a question for a plumber, not for me. Very sorry, but I have no idea. Have to ask a heating engineer that, I'm afraid. Okay. In my scenario, so Richard, back to Richard's question about underfloor and radiator in the same room. In my scenario, the floor would take longer to heat than the Rads and retain heat for longer. Can this be accounted for? Yes, Richard, but to be honest, this is when we move away from a more standard style heating system and into something a little bit more complex and the 20% rather than the 80%. I'd recommend we look into something like that together. Rather than me try and blag it on a webinar. On a webinar, I'd much rather look at the 80% of scenarios, and then the 20% of stuff, that's what we as partner coaches exist for. Just phone us and we'll go through it one-on-one for your particular scenario. Okay, Peter, you mentioned that only use one room controller per room. I have a house with master, dressing room, ensuite and lounge, but when creating through app, this looks really bad. So I've used 4 room controllers, but labels the area and is tidy in app. Not entirely sure what you mean, but yes, it's 1 room controller per room. But if you have like multiple rooms nestled off each other that all need a room controller, but it looks messy in the app, I would actually recommend using our new linked function blocks feature, because then you can have all of the sub rooms just nestled off the main room without being displayed separately in the app. Okay, Ryan has to shoot. You're welcome. Okay, Peter, with your question about H2 and temp controllers, again, that's one to ask me directly because I'm not entirely sure what you mean by that question. Lee, in the hot water example, would it be safe to let Loxone control over temp of the hot water cylinder via the tank stat? Again, it's for you as a professional to answer. I would do it every day of the week because I trust a mini server to read a digital input. I trust the mini server to then control a relay appropriately. I mean, you could equally argue that if you're putting live through a cylinder stat, which is then feeding a zone valve, that cylinder stat could just as easily, the relay and that could become fused and it could hold the water on forever as well. So you've always got a potential point of failure. You've always got something that could fail. And what do you trust? I trust Loxone. It's down to you as a professional decision whether you do as well. Cool, guys. Right, I think that's all the questions gone through. Again, if anyone wants to ask anything with microphone rather than the Q&A, feel free to just use the raise hands feature and I can unmute you. In the meantime, what I'm going to do is I am going to launch this poll here for what topics you would like to cover next. So I've just made a few suggestions on here. I'm going to launch the poll. Please, can you all select what you would like to cover next time? And I'll leave that poll going for a few minutes. If you have any other suggestions for what you'd like covered, email me and I'll add it onto the poll list for next week, for next time. So this poll I will do every session. So it will always be you guys deciding what you'd like to cover. And if there are any topics that I haven't written on there that you would like to cover, email me them. Peter, I can see your hand is up. I will just promote you to a panelist, and that should allow you to talk. Okay, Peter, you should be able to unmute yourself now.
Hello.
Hello.
Hello. So the basic thing I was asking about the underfloor heating is so on a job that I'm on, there's an underfloor heating manifold in the downstairs hall, and one manifold has one zone valve to do one half of the hall, then which obviously has its own pump and zone valve. Then there's a second underfloor heating manifold which has another zone valve and has its own pump and things like that. So whenever I've created it in the app, I've had to create it under 2 separate zones on one area. So would H1, H2 be better for that?
Okay, so but both of these zone valves and the manifolds still both feed the hallway.
Both feed the hallway, but they're off 2 manifold valves. 2 separate manifolds.
I don't see why that would matter. Just open them both at the same time. Have them tied to the same thing.
But then whenever I put that through the temperature controller, so whenever we go through the temperature controller and we select what's actually switching on and off, that zone, then I could potentially have. I'm trying to think of what way it's easiest to explain. Whenever I went through it, whenever the customer is looking at the app on the screen, he sees hallway as one intelligent temperature controller.
Well, the intelligent temperature controller can't be seen in the app. It's completely invisible from the app.
Sorry, intelligent room controller. He sees 2 separate intelligent room controllers.
Okay, so what you want to do is you want to only have one intelligent room controller for the hallway, but then just assign that one room controller to 2 different intelligent temperature controllers for the 2 different zone valves.
Right.
And then that will make sure that both of the zone valves open when that one room controller is needing heat.
Right. That's okay.
And then that will fix that for the customer in the app as well. It'll look with only one room controller in the app.
Right. And the other one was just with a master bedroom, dressing room, ensuite, and lounge. That's one big massive room, but I'm going to try it out with the link setup.
Okay, so when you say it's one massive room, is it like just a single underfloor heating zone for that entire area, or is it separated with different valve actuators?
4 zones. So it's actually 5 zones. So.
Okay, so it is separate. It is separate valve actuators.
Yes, and separate temperature controllers.
Okay.
Switches per room.
Yeah, so this is very easily solvable. You have your 5 intelligent room controllers for the 5 rooms that you essentially have. I'm just going to make 3 just as an example. On all of the smaller rooms, untick the use tick box that they're not displayed separately in the app. And then on the main room, say the master bedroom, link the other 2 into the master bedroom's room controller, and then they'll all show nestled underneath the master bedroom's intelligent room controller. And you won't have 5 separate things showing on the app, just one, with the other 4 nestled underneath it.
Right.
Linked function blocks.
The link, you know.
Mm-hmm.
So I'll give that a try.
Cool. I can see there's still a couple of people left to vote on the poll, so you've got a couple of minutes left if you wanted to. And then while we are just waiting for that, has anyone got any final questions they'd like to ask me at all? Doesn't have to be directly about heating as well. If you just want to have a random question about something else, feel free. Nope. All right. In that case, I will say farewell. It's been a pleasure. I hope you guys have all learnt something. This recording, as well as this config file that I'm working on, will be available by the end of the week on Academy Ocean, which is our online academy. So feel free to look back at it then. I will also confirm after the poll has been finished of which topic was the most requested for the next session. There is one question that's just come in. Bill, on controlling hot water, it depends if unvented or open vent cylinder. Unvented must have a non-resetting over temperature cutout wide in series with the heat source. There you go. There is your answer from a plumber. Sorry, Bill. Sorry. No, not plumber. Heating engineer. Sorry. Really sorry about that. So there's your answer from a professional heating engineer. So it depends if it's vented or open vent. Adrian, can you get a copy of the layouts, please? Of course, if you are a member of our WhatsApp group, then the layouts were posted on there over the course of the last 3 weeks, and you would have been able to see them already. So for anyone who isn't already a member of our WhatsApp group, please make sure that you join it. I don't have the details to hand. Just get in touch with us in the morning and we can send you the details for getting added onto there. All right, excellent. Oh, yeah, sorry.
Also, I would say if you're not 100% on wiring for heating systems, download the Honeywell wiring schedule app onto your phone and you'll get all the wiring setups.
There you go. There's a top tip there. That's one of Peter's top tips, not Hugh's top tips. For me, I just wire stuff in and see what blows up. ETA on the Gen 2 NFC code touch July is all I have, I'm afraid, at the moment, Dave. I haven't been, to be honest, keeping track of estimates myself. I'd have to check with a member of the team. That's now that we've got a warehouse manager, he deals with all of that stuff, but I'll check in the morning. Okay, thank you very much, everyone. It's been a pleasure. I'm going to end that poll now, and I will catch you again next time. Goodbye.